But I just want to make some quick announcement that the second individual assignment will be released next Friday. Next Friday, we'll be having another section. So after that section of next Friday, I will give you the second assignment. And Friday, before we start, we have the second quiz on what we're going to be discussing now. 10 to 15-minute quiz for the second quiz. Okay, so after the second assignment, I will be giving you a project, a good project, and you'll be working on for the next couple of days. Okay, so let me share my script now. So can you all see my screen? Please let me know if you are seeing my screen. So I guess everybody has access to this notebook. I think I uploaded it on the course website. Everybody has access to this notebook. Please, I want this session to be interactive. So if you can mute yourself and speak. Everybody has access to this notebook. Yes or no? Amma, I see Amma there. Do you have access to this notebook? So just want to confirm if you have access. So I'm not hearing her. Maybe Gomez. All right. See. Yes. Okay, today, as I say, we'll be discussing about 2 or 3 libraries in Python that will be very useful for us: NumPy, CPy, and Matplotlib. So I think when I was there, someone asked me a question about NumPy, and we couldn't. I told him that we are not there yet. So here is the answers of his question. NumPy is a Python library that helps us to manage some data, some homogeneous data. We have learned about list, we have learned about dictionary, we have learned about a lot of things, but this NumPy library will help us to manage efficiently the data, and also the environment is nicely configured to use it, to do some stuff, to do some operation, and even it is faster than if you want to do some operation using list. You might maybe have some problem, and it could maybe take a lot of memory before running. But here now NumPy is fast and efficient way, okay, of manipulating some data. And as I say, what is the difference between Python list and NumPy? First of all, we know that the list can contain some heterogeneous data. We could have some integer, we could have some string in the same list. But here for NumPy, we only deal with one type of data in our array, one type of data. And another difference is that NumPy is fast and efficient way, very, very fast, and give us the environment to manage nicely the array and the data inside our array. So before we use NumPy, we need to first import. We learn how to use it, and first of all, we import NumPy, and we can work just using NumPy. But for short or abbreviation, we just import NumPy as NP. So every time that you see NP, that is, we refer to NumPy as abbreviation. So we import this library as NP, and then we can do anything that you want. For instance, you can get some help. So here we are creating now an array. It's the same, you see those two cells are doing the same thing. We import NumPy as NP, and we use directly NP, but we could just import NumPy and we use NumPy directly. So they are doing the same thing. Okay, so while am I talking? So if you have questions, just feel free to ask, interrupt me anytime. If you have question or something is unclear. Okay. So array is a sub package from NumPy. Okay, so when we want to use array, we import NumPy, we import from NumPy the array. And that's what we are doing there. Okay. So if you see, you have access to the notebook, you can run at the same time we are moving. So basic way to create array. Let's say we want to create an empty array, NumPy array. So we denote it as D, and remember that we already import NumPy as NP, and the syntax is np.array, and it contains an empty, nothing inside. Okay, when you run it, you will see it is an array that contains nothing. But we could also insert some numbers, some integer, and you see that all those values are from the same type, and they are integers. Okay. When you run it, this is the format. Give you array and give you the element in that array. But let's suppose that we have this. It will still give you, you see, we are writing 0.535 toto. but he will view all the elements as a string because he deals with only one type of objects in the array, homogeneous. So even if we are understanding that, okay, we are inserting the integer 35 and total, but he view all the value as a string. That's why you see the quotation here. Okay. So suppose now that we want to create an array that evaluate x to power 3 for x in the range 0 up to 50. Okay. So this is an array that you are creating, an array of numbers at the form S cubic when x is from 0 up to 50. And it is doing exactly what we ask him to do, 0, 1, 8, and so on. Okay. You can specify the type of your data directly in the array. We want that he consider all those values as a float, and we specify the type. So that means that there are some computation that we can do in the type of float that maybe if we denote this as maybe a, and we want to evaluate the exponential, or we want to evaluate the logarithm, this can easily we can easily work with this. Okay, so also we can create some array the easy way. We can create an array that contains 0, 0, 0, 0, 0, 0, 100 times array np.0 if you want an array that contains 5 entry of 0. Use 0. And if you want to use ones, only 1, 1, 1, 1, 1 in that array is np.ones. Okay. We can also remember in our previous slide, we deal with how we can find some range, set of number that is increasing by step of 1, 0, 1, 2, 3. And also here, when we are using array, we can use numpy.arrange. That means that we want to have a list of integer from 0 up to n-1. Okay, Samuel, you are saying something? Okay. So if there is a question, please stop me anytime. Please check your microphone. I'm not hearing you very well. Okay.
Prudence, he has no question, so you can continue.
Oh, okay, that's all right. Yeah, that's all right. Thank you. Right. Okay, so all right. So here now, what are we doing here? We can create some array of number, a range of number that are not necessarily an integer. We want some number from 1 up to 2.5. And okay, can you see my screen now? Okay, thank you. So we want to create some set of numbers where maybe we want to do some operation from the list or the array from W from 1 up to 2.5 with the step 0.5, 0.25. So we can specify directly like this. 1 is the first element, and 2.5 is the last element, but we are moving 0.25, 0.25. Okay, so here now, when we are using the linspace, we specify the starting value and the last value and the number that we want to have in our list. That's the 3 parameters when we are using linspace. The first value here is -1, and the last value here is 4, but we want to split the interval -1 up to 4 into 11 different points. So he will subdivide this and give us the number in that range. So another way is, okay, we can find the number of points directly by taking the last point B minus the first point, which is -1, divide by the step, which is 0.5. And this gives us directly the numbers +1. So we are splitting the interval -1 to 4 into 11 different points, but each point, the distance between each point, one to the next one is 0.5. So you can use linspace to generate such kind of array or range. Okay, so what we are doing here is we are getting the number of points in our interval. Here we are also moving from 0 to 9, and we want to have 9 points. 9 points in our array, the list. So now, how can we access the element in our array? Because for sure we'll be doing some operation, we'll be taking some element from our array and manipulate it. Yes. Yes.
That's the use of
No, I'm not hearing.
The use of endpoints is equal to 4.
N equal to.
You see, after the 099, you have a comma, and then endpoint equals 4. What is that doing there?
You mean this one, b equal to 4?
No, before that line 14.
So this one. You mean this one?
No.
Please, I'm not hearing you very well.
So Prudence, he's talking
Yes.
about after output 11, then you go to input 14. That is numpy.linspace 099 endpoint equals false.
Yes.
Yeah. Around that side, move the cursor up a little to input 14. Yes, that please.
Yes, okay. So what we are doing here, we are generating some numbers from 0 up to 9. Okay, our range here is 0 to 9. But you are asking your question why we didn't get 9 at the end. But here, remember that we are splitting into nine different points. If you create you are generating some numbers and you want to have exactly 9 and you're starting from 0. So that means that you need to stop at 8.
Okay.
Yes.
But after the 9, we have a comma endpoints equals 4. What is the use of that number?
I think the communication is not okay. I'm not. Maybe you are far from the microphone.
Okay, so Prudence, can you hear me?
Yes. So yes.
Okay, so the question is asking us
yes.
On that line.
Yes.
So on that line,
yes,
we have np.linspace and 099. Then there is an endpoint equals false.
Yes.
He's asking why you have that there. The endpoint equals false. What is the purpose?
Oh, okay. And now, okay. I see another question. So look at here. We can instead of using the syntax linspace start stop and the number of points. When you write it, it gives you by default 15. It gives you by default the number of points here, which the last point can be included. But you can also use an alternative syntax here, which is linspace start, which is the first point, the last point in the interval. And here is the number of element in that interval. But we are specifying here that, okay, the last element in our interval is not necessarily needed to be included, because our number of, it depends on the number, how you split your interval. So if you set this as true, and maybe change the number of different points that you are splitting, and I think you will find 9 included at a certain point. Okay. All right. So we can now have us access element in our array. We can pick the elements here you just specify, okay, we want the first entry, and is that counting from 0? Here we want the last one. It gives you 15. And also you can take some subset of the array, and it return you element from the index 2 up to 4. That's what it gives you exactly. And notice that between those two line of code that we are writing, what do you notice? We already specify A. A is our list, our array that contains those values. And we want to print all the elements in that list. Okay, we want to print all the elements in that list in a different way by using print output. So here now, since A is our array, I want any element I in our array. I want to find out any element in A, and that's what I'm just writing there. I'm traversing all the elements in 1D array. But look at here, there is an alternative way to do that. The I here is in the range. This is the index. You are taking the index here. So when you are taking index, you print A with respect to the index. Do you notice difference between those two? They are doing the same thing, but this I here is the element directly from our array, but this I here is the index. So therefore, you need to print A with respect to the index. So they are doing the same thing, eh? Well understood, I guess. So inside our array, you can find out some condition or maybe have some restriction. For instance, I want our array that is given to give me all the value that are greater than 5, all the positive value. So how can we do that? You just specify the condition inside the bracket. So when I run this, what does it give you? Look at our A. This is our A. And this is what is giving you. Who can interpret me what is saying? What this line of code is doing? This is our A, eh? And this is what we get now. If you run the second one, this is giving you all the list, all the element that is greater than 5 in our A. Let me run A from the beginning. Okay. You see, he's going through all the elements in our array, and he's removing only the number that is equal to 4. You see, 4 is missing there. And here we are taking all the entry in our array that are greater or equal to 5. And that's what you obtain exactly. So whenever you want to make some condition or restriction in an array, you use this syntax. Okay. So there is an alternative way to do this. You can set up the condition, what you want, the condition. Our condition here is that we want all the elements in A to be greater or equal to 5. And we write a bracket, the condition. 5 up here is the condition. So you can set up your condition, write the line of the condition that you want to, maybe you are looking for all the number that are divisible by 4, and at the same time negative. You write this condition. Maybe you can use a conjunction, disjunction, and inside the bracket of the name that you give to the array that you are dealing with, you can find out. So that's what this is giving you directly. So this one, he's giving you all the elements in our array A that are strictly greater than 2 and at the same time less than 11. Okay. So just a small exercise. Can someone write the code to select element of faith that are divisible by 2 or 5? And you can share your screen. Just give you 5 minutes, or maybe 5 is too much. 2 minutes. It's one line. So please, Fred, you can also move around and see if they are working.
Okay.
Thank you. So let them do this, and if someone has done it, you can share your screen, your answer.
Who wants to share their screen? You want to share your screen? Right, currently select elements that are divisible by 2 or 5. So if it is divisible by 2, we know the modulo is 0. And if it is divisible by 5, we keep the number of the 5 is equal to 0. Saying that
Okay. A volunteer? Okay, I see Judy Kael. Yes. Okay, you can share your screen now. Judy Kael, so if you want to share your answers, please share your screen. Okay. So I'm not hearing you. Can you unmute yourself?
Okay. Voilà.
Okay, it's work.
Yeah.
I see I think
Yeah, this part, this line.
yes, this will give you the element of a that is divided by 2, but you need to
And
also add 5 or. So after the bracket, you can use or. Yes.
what? Okay, this all. You get it.
Yes, exactly. When you use that, it work. Yes, perfect.
Okay.
Okay, thank you.
Yeah.
So I guess everybody try it. Let's continue.
Question.
Yes, someone has a question, eh?
Yes. Um, he used the vertical line. So
Yeah,
what's the difference between the vertical line and the plus? Because I used plus and it worked.
yes. Okay. Your question is if you use the vertical line, is also saying or those two are doing the same thing when you are dealing with an array.
Okay.
Yes, they are doing the same thing. You can use either a vertical line or plus it will work. Okay. So
Please, sir.
yes,
If I need to do this operation in the first operation in the last operation.
yes, the end you can use this one as we are doing here. You know, you see the previous example that we did. We want the number of all the elements of A that are greater than 2 and less than. So you use this.
Okay.
Yeah.
Thank you.
Okay. So let's continue. We want to create some multi-dimensional array. Remember what we are dealing with is a one-dimensional array, and you could have multi, example, two-dimensional. So here now we are creating multi-dimension or two-dimensional connotes a matrix, and you are familiar with matrix. So we are creating a matrix of size 5 times 4, where all the elements are 0, 0, 0, 0. A way to do that is just numpy dot 0, and you specify the dimension of your matrix. And if you want your matrix to have only one, you use ones. Okay, that's what we discussed previously. So just notice here now that you need to specify the size of your matrix when you are creating a multi-dimensional array. And you can have an identity matrix of size 4. And here, what you are doing here is, you know, here is a principal diagonal. But when you want the diagonal before, they have the different type of diagonal. And here they have the principal and the secondary and all this. But this K here is telling you that, okay, we want to have 1, 1, 1. It means 1, 1, 1. Throughout this diagonal, -1. So is the diagonal just before the principal diagonal. That's, you specify -1. So if you specify 1 here, now, if K is equal to 1, you're gonna have 1, 1, 1 after the principal diagonal. You could specify K equal to 2 and so on. So suppose now that we want to evaluate this kind of matrix, let's interpret what this matrix is doing. To this I, it's saying what? We want a matrix of size, a square matrix of size 10, which have only 1, 1, 1. So is this I 10 K equal to 0 here is evaluating an identity matrix. So you only have 1, 1, 1, 1 the principal, the diagonal, and then you multiply by 2. So that will give you 2, 2, 2, 2, 2 at the principal diagonal and 0, 0, 0 everywhere. And you subtract this matrix. Remember, this matrix also is a 10 by 10 square matrix, but k equal to 1. After the principal diagonal, you want to have 1, 1, 1, 1, 1. And similar to this one, when we evaluate, you get this matrix. Okay. So you can have some operation if you want to have a certain kind of matrix. You could use directly this, or you could manipulate identity matrix with zero matrix, with A matrix, and get the matrix that you are looking for. So suppose now that
Question.
yes, go ahead, please.
Back to this matrix. So
Yes.
the subtraction you're doing
Here, the first
what
or
is
the second?
so the input. So you have 2 times the identity minus
Yes.
the identity minus the identity. Like, I don't understand the subtraction that you are doing over here, because if you do it,
Yeah.
I think it's 0 or
No. Look here. Here, first, this part here will give you an identity matrix multiplied by 2. So the principal diagonal will contain 2, 2, 2, 2, 2, 2, 2, 2, 2, and 0 everywhere. Okay? For this part. All right? And this part, let's evaluate this matrix, what this matrix is giving you. It's giving you 0 everywhere. Even at the principal diagonal, you have 0, 0, 0 everywhere. But just after the diagonal above the principal diagonal, which is this one, it will give you 1, 1, 1. All the entry at the diagonal above the principal diagonal is 1, 1, 1, 1, 1, 1, and 0 everywhere.
okay. So if I understand what you are doing,
Yes.
subtracting that from the matrix, so you are just allocating -1.
No. Look, this one here is a matrix. We are now doing operation among matrices. So we are taking this matrix minus this matrix minus this matrix. Okay? So I'm explaining to you now what is this matrix giving you. This matrix is giving you 0 everywhere, except the diagonal that is above the principal diagonal. And for that, you have 1, 1, 1, 1, 1, 1. And when you multiply by, it's like a coefficient, you multiply a matrix by a coefficient -1. So you give you -1 everywhere. Is it clear?
It's clear.
Okay. So here now, what we want to generate a matrix again, a matrix by using diagonal LK. This L here is a list. So initially you have a list that contains some entry, and you specify K. And of course, it will return you a matrix. And what will be the shape of that matrix? It will give you a matrix of size M, where M is the length of N plus K, absolute value of K. And when you take that matrix is 0 everywhere except the kth diagonal. The kth diagonal is looking at the principal diagonal. The first diagonal, if k equal to 1, is the next diagonal that is above the principal diagonal. K equal to 2 is just the second one here. Okay. So for that diagonal, you now replace all the elements by our list. So suppose now that we have a list which contain 1, 2, 3. and our K equal to 0. What is this matrix is giving us is the size of the matrix is the size of the length of our list, which is 3 plus K. Our K here is 0. So we have a matrix 3 by 3. Okay? And we now replace at the principal diagonal 1, 2, and 3. That's what this is giving you. Let me run this. You see? So we know how to find the size. The size is given by this formula. But now at the diagonal, 0 diagonal means the principal diagonal. And it contains all the elements of our list. So suppose now that you take -3. -3 will give you a matrix of size. Length of our list here is 3 plus 3, 6. So you have a 6 by 6 matrix. And what is -K diagonal? This is the 0 diagonal. Okay, the 0 diagonal is this. The -1 diagonal is this. -2, -3 is this. So -3 diagonal contain all the elements of our array. Okay. So remember we already discussed about a random, how to find random number in a certain range. So suppose now that we want a matrix of size 2, 4, and we want some random number from -2 to 5. We want to generate a matrix of size 2, 4. We take all elements randomly from -2 to 5. That's how you specify it, and this will give you a random matrix. Okay. So this is another way to create a matrix. You combine list. You combine the array inside array. So this will give you the first row and the second row. You write the list of the row, the first row, the second row, and the third, and that's you form the matrix. So this, how many row we are having so far here? We are having 4 rows. And this gives you a matrix of type 4 times 3. So you can write your matrix directly like this. Okay. So you can access element in that matrix. So when you write M0 here, M0 is giving you row. M0 is giving you row because it's an array of array. So you can look, you can see very well. This is the array that contains some array again. And when you are taking M0, it's giving you the rows. Okay. Also, you can get some specific element in that matrix. The element at you want these elements. This one, for instance, M0 here. M0 gives you the first row, and when you are looking at maybe the first element, if it is the first element, then you write M00. But if it is the second element, you write M01. M01 here is giving you 4, I think. Yeah. So also you can use this sentence. they are the same. So you can get any element from your matrix by this manipulation. Okay. So what are we doing here? We are creating a matrix. And that matrix, we are generating some elements from here from 0 to 6. That means that we have our first row as a integer from 0 up to 5. So our second row here contains elements from 10 to 15 and so on. So that matrix is what you are seeing there. Okay, and you can do some operation on that matrix. So here, what we want to see here now is that given some list, you want to maybe reshape or get matrix from one array. It's possible to do that. So you have our array that contain those, yes.
Please.
Yes, go ahead, please.
Line 47.
Line 47.
This line.
This one?
No.
47, there is no 47 here. Here. After this one is 51. Eh? Judy Gael.
Yeah, this line.
Which line? 46? Which one?
This line.
No, I don't know which line you are talking about.
Okay, and this is the same where we went at.
So I'm not hearing you. It's like you mute yourself.
Inputs 129.
I'm not hearing. Okay.
129. Inputs 129.
129. Yes. Okay. This line.
Yes.
Okay.
So
okay.
the last line there is what he's asking about.
Oh, okay. This one. Yes. Okay. So we are generating some integers from 50 to 56. That's what is given here. 50 to 56. So if you are generating element, if you are using arrange NM, it will give you some list from N to M minus 1. Is that all you're asking? So here now, what we are doing here, we are using arrange to create our matrix. So we are seeing different form how we can insert, create matrices. Look, here you can create your matrix using some known matrix like identity matrix, or zero matrix, or I matrix, and yeah, different way of creating matrix or quick fast way. Okay, so here you can decide to write the list by yourself, like what we did here. If actually you want a matrix, you can write, I want a matrix that contain 0, 1, 2, 3. The second row contain 50, 51, 53, and so on. The third row, and so on. And here we combine all those things to give you a matrix. But it's hard. So sometimes if you want to write it like that, sometimes it's hard. So suppose now that you want to create this kind of matrix, 10 by 10, and you decide to use to write by yourself all the row, I think it might be challenging sometimes. For fast way of writing matrix, that's what we are saying. And if you want some consecutive number, from 50 to 56, you just write a range that will give you the last row. So this gives you the order, the order. Okay, let's move. Hope I answer your question.
No.
Okay, so what is the question specific?
So at the where you were doing the slice, the indexing and the slicing, math,
The intake.
the slicing, yeah, the last part.
This one.
Yes.
Okay, so let's do this. Okay, what are we observing? This math here is giving us this kind of matrix, this matrix. I think the size of the matrix is 6 by 6. Okay. So let's look, what is this doing? Okay. Okay, see. Let's try this and see.
Please,
Okay.
I get it.
You get it now?
Yeah.
Yes. Okay. So you see, when we write this giving you
If I write this line,
yes.
One, we could specify one if one line and 0 the first element in this line.
Yes,
For
exactly. Yeah.
Take also a 2 line with third line and element at position 2.
Yes. Yes, correct. Yes, correct. Okay. Thank you for the remark. All right, so let's continue. So we can, given a list, you can find out some matrix from that list. So suppose now that we have a list and then we want to extract or form a matrix 3 by 3 from that list. You can use reshape and find out a matrix of size 3 by 3. Okay, so let's move fast. Okay, so we can do some basic operation on some array. We can do addition and when you specify the type of your array, you can do some addition. You can multiply by a coefficient. You can take. So what you are doing here, you are taking the inverse, not the inverse of a vector, but the inverse of every element. When you write 1 over A, you are taking 1 over X for X in A. You can take your array to a certain power, so it will elevate every power to 2, to the power 2, every entry, every element of your matrix A. Okay, so you can do some, you can check the divisibility, you can take the exponents, and you can evaluate the cosines. So it will evaluate the cosines of every element of your array. So you can do some basic mathematical operation on your array. So suppose now that you want to evaluate this polynomial. This is a polynomial. Okay. For all the value, and this actually will give you a list, an array. And we know what this array is saying. Okay, length space of minus 505. Okay, and we want to evaluate the polynomial at each element in our array X. Simple, eh? We already define X as an array, and we evaluate the polynomial, and this will give us directly the value. Also, we want to evaluate this polynomial, and this polynomial will give you also is also an array. So it is an array that evaluates this function at every value when X is equal to maybe the first element of our array, the second element, and so on. Okay, so this is also a very, very well-known function in Python that you'll be using sometime if you is a compressed way to define a function. If you define a function of one variable, you specify the variable of a function and the expression of your function. So here, X is what we say here, what we define initially here is an array, and you want to evaluate Fz. So that means you need to evaluate, you take the first element of our array and evaluate F of S, which is S squared, the second element, and you return you an array again, which take value, the expression of this function. So this is part of Python, and you can use whenever you are defining a function, one variable, two variable, you write it and write the expression to give you directly. Okay, or you can write your function in a normal way. Okay, in a normal way, we define a function, define and you name your function and write the arguments and what this you want the function to return to you, and that is S plus 1 squared, and you can evaluate it. I think I didn't run this. Okay. So it's saying, so maybe we can return directly this instruction. Let's see. Okay. So it works now. Also, we can define a function with a certain condition. So, and evaluate. Yeah. So let's try this exercise. Let's try this exercise in 5 minutes. We want, based on what we have seen here, you can define a function that return you 2x whenever x is equal to 0, every element that you are taking from your list, you check the value, because here, remember that x here is an array. So whenever you check every element that is greater than 0, you double that element. And if it is not, you add +1 to that element. That's what this function is telling you. Okay. So suppose now that here we have 2 array. 1, 2, 3, 4. Another array is 2, 2, 3, and yes. And you want to create a function.
Please, what is the
Yes.
essence of np.vectorize? That's over there.
Yes. So that because look, because of this condition, if you write this, you did. My computer is frozen now. Okay, so I'm trying to run it, but it looks like my computer is frozen. I cannot move anymore. So looking at those two, you first notice that the function that we define here first is we do not add any condition. We just want the function to return s+1, no restriction. But when you are giving certain condition, when you are manipulating the element in your array, then you first need to, when you are saying vectorize, you are giving him to have access to the particular entry in your array. That's the essence of vectorizing thing. Otherwise, if you don't vectorize, you cannot have you cannot specify, okay, looking at every element in our array and considering only the positive one, you double them. Only the negative one, you add them. So the essence of vectorizing is for a specification of restriction or some condition. That's why we I think I need to restart something like this. Okay. Okay, my Jupyter notebook is not working. anymore. So I need to start my kernel again. So can you try that exercise that's in your Jupyter notebook just after that, after where we were? If you have access. Yeah. Meantime, that's I'm starting my kernel. Okay. So did you all try the exercise?
Yes.
Okay. So let's continue. Sorry, that's a laptop. That's an issue. Okay. Okay. So we already have seen this, how to set up some condition on a specific list element of the list. Okay, so you can get the dimension of your list and also the size. So ND is giving the dimension. Here is 1, and you can get the shape and the size. Okay. So suppose now that you have 2 or 3 arrow, and you want to have a list that contain all those rows. You just need to flatten all the row together and to give you 1 row. Okay, so given your list or the array, you can get the minimum, maximum. You can do some operation. You can get the summation of all the elements. You can get the mean. You can get this standard deviation. You can have some few operation on that list. Okay, using those method. Okay. So here, why we're introducing axis 0, axis 1. So from our matrix B, okay, this is our matrix B. I didn't run from the beginning. Okay. So let's look at the matrix B. It's a matrix 2 by 3. And we want to compute, we specify the axis. That means we are looking at column. Within the column, we want to find the minimum within the column. That is axis 0. And axis 1 is we are going through the row. So we find the minimum of element looking at the row. 1, 2, we take the minimum. 3, 7, we take the minimum. So you can specify the axis. The axis 0 means that you're going through the column. The axis 1, you're going through the row and do the operation that you want to do. You can also do some operation like multiplication. And here is matrix multiplication. Matrix multiplication. So suppose now that you have the matrix M, this, and the matrix N. When you write dot N M is giving you the matrix multiplication. It's not the dot product that you should know. Because the normal dot product is you multiply 1 every element. The first one multiplied by, normally should be 1 multiplied by 1, 2 multiplied by 2. But you here, when you write dot NM, that connotes matrix multiplication. Okay. But when you are using multiply, then you are doing multiplication component-wise. Every element of M by N. Okay. So you can get some few operation on matrix. You can get the trace of the matrix. That means the summation of L or element in it at the diagonal. You can get a transpose of the matrix. MT. So you're getting the transpose of the matrix T. Then get a film operation. So this says that you can try it as a free time. Write a Python code that computes this matrix to I plus the transpose of the matrix R multiplied by the product of matrix R by X. So R and X are specified. So what you just need to do here, I is a identity matrix. We know how to write an identity matrix, and we know how to write a matrix like this. You can write it as the first row contain the array 1, 3. The second row contain the array -1, 7. And also you define the matrix X. The first row contain 5 and so on. And then you now do this operation. You take 2 multiplied by the identity matrix. Okay, we have seen previously how to get an identity matrix. And this is the transposition, the transpose it. This is how you take the transpose of a matrix. Matrix multiplication, you use dots, and that's all, and you can compute this easily. Okay. So what we want to learn now is how we can solve some linear algebra, basic linear algebra problem using NumPy, and how to solve a differential equation using NumPy as well. If you want to get the determinant of matrix, first you need to import this package, linear algebra, from NumPy first. Okay, and now you allowed to get the determinant of a matrix. You can get the inverse of a matrix easily. So setting your matrix as A now, in order to get the determinant, you need to use the package library linear algebra. Okay, and to give you the determinant, you can guess the inverse of the matrix easily. Okay, you can get the eigenvalue, the eigenvector of your matrix easily by using linear algebra eigenvalue, eigenvector, and give you that. Okay, in the first assignment, if you remember, I asked you to generate some polynomial and write your own function that compute the multiplication of polynomial. If you remember, in the first assignment, I think I upload the solution. No, I send it to Fred, and in case you want to view your mistake in the first assignment, you can check with the tutors. Okay, so I want in the first assignment, I don't want you to use Python, a function that is built in Python to compute the product of a polynomial. Right? You write your code from the scratch. But here, you can use, from the notion that you have seen now, using NumPy, you can do the product of a polynomial very easily. So a polynomial is characterized by an array. So all the coefficient of that polynomial is taken as an array. So looking at this polynomial, the corresponding array for this polynomial is 2, -1, 0, and -5. So given an array here now, we can get the polynomial corresponding. Okay. So if you specify to Python, okay, I want the polynomial that is corresponding to this array, you use poly 1D, and that will give you exactly this polynomial, 2s³ minus s² minus 5, that is giving you. So those are the coefficients of the polynomial. This is the coefficient that multiply the variable at the power 0, 0 times x to the power 1, and so on. Okay. So you can also get a specific value of that polynomial. We want to evaluate my polynomial P at 0. That is n numpy dot Oliver value. You are evaluating the value of the polynomial at 0. Okay, you can also do sum of the polynomial. You can do also product of polynomial. Okay. So this is, you see that with the function built in Python is very easy, eh? But that's what I wanted you to write this code from scratch in the first assignment. Okay, so with what you have seen now using NumPy, can we evaluate this polynomial? I think it's easier. So you just specify the array corresponding to this polynomial. Okay, so the array here is -2, 0, 0, -2, 0, 3, -1, something like that. So, and to get the value of this polynomial at 3 square root of 2, you use this. Okay, and determine the root. The root of P using the NumPy function root, and you can get it. Oh, but because of time now, should we try it? Okay, please. Can we use 2 minutes? 2 minutes to do that, to 3 minutes. Okay. A volunteer to share his results. Any volunteer? Okay. Because of time. Okay. This is simple, eh? And you get, if you want to get the root, you use root, and that's all. Okay, so we have a polynomial corresponding to this array, and you can evaluate the value of that polynomial at 3 square root of 2 and get the roots of that polynomial. So we have three roots, -2, 1, and 0.9999. Any questions so far? Any question, remark, comments?
So the polynomial that you type
Yes.
is -2, 0, 3, 0 minus 1. Or
Okay, let's look at what this will give me. P. So we have seen here, if I want to look at the expression of the polynomial rents and P dot. So let's use this here to find out. So this is small p. So, okay, I think I'm taking different polynomial. Okay, so that's all right. Thank you for the remark. So you can modify the array, this array. Instead of taking this, you choose the coefficient of this polynomial. Okay, so it's not the right polynomial that I'm taking here. Okay. Thank you. All right, let's move. So please, after this class, take time to go through the notebook and work on the notebook by yourself. It's very, very important. Okay. How to solve a system of equation in Python. Suppose we have a system of two known or three unknown linear equation. Yes, Emmanuel?
defining the polynomial. You said
Yes.
poly 1. You said poly 1D. So
yes,
do we
of
have
P.
do we have 2 dimension?
Yes, is a polynomial of one variable. Here we have a multi-dimensional polynomial or polynomial of 2 variable or 3 variable.
Oh,
Right?
okay. So the 1D means that it's one variable.
One variable, yes.
Okay.
Yeah. Okay. So there's also a way to define polynomial of multivariable in Python as well. Yeah. So you can look into it. System of equation in Python. This is very simple. We want to solve this equation. First, we extract the matrix. You can write any system as a matrix multiplied by x equal to a certain b, which is a vector. So we extract the matrix from this system, the first system, A. Matrix A here is 3 minus 9 to 4. And we can rewrite the system equivalent to a certain matrix A multiplied by the x that we are looking for is equal to B, which is the vector from the other side, minus 14 and 2. So 2 ways to get the solution. The first way is to just take A, multiply, the A inverse, I guess. We know how to evaluate the inverse of A multiplied by the vector B. And you get, knowing that the matrix is invertible, right? So you check the determinant. But you can also use the package linear algebra, and solve. Okay, you use this, solve A and B. You specify the matrix A and the vector B, and it gives you directly a solution. That's all. See, very simple. So for this one also, you can extract the matrix. So here is a matrix of 3 by 3. You know how to write a matrix. You start writing the row. You can write it like this: the first row, the second row, and the third row. And you give the matrix, and you specify the vector C, which is the vector 6, 1, 1. Okay, and you use linear algebra package, solve and get the solution. M and C give you the solution. Okay. So that is solving a system for a linear system. So you can also solve a non-linear system using Python, finding the symbolic solution. You can also do integration in Python. Okay, you can integrate a function. But here you can import, you import CPy, integrate, and you name it as square. Okay, and specify the value, the first value of your integration, and the last one, A equal to 1 and B equal to 1. And remember, I always explain to you why do you use the function lambda. Okay, is easy way to define a function. Instead of doing, okay, define f of x and write the instruction and return, you can just use lambda if you are dealing with the argument x. So we want to evaluate the integral of this function f of x, which is equal to s to the power 7 minus 1. So we've defined the function, we define the value of the integration a and b, and do not forget to import CPy, because CPy contains some sub-package of integration or ODE, and you want to solve some differential equation. This CPy contains all those sub-package that you can use. Okay. And specifying this now, you import integrate as this thing. You can name it something else, and then you are evaluating the integral of f at from A to B and giving you the value. That's all. Do the same thing for the second, compute the integral, the second integration, you can do that. But look at here, it's going from 0 to infinity. Yes, yes. Question? Yes, question.
Function.
I cannot hear you. Sorry. Can you repeat your question?
Previous.
Previous, okay.
Yeah, but look at this one.
Yes.
Equals to comma A, comma B. This 0 stands for at the end there is a 0.
Yes, yes.
Is this 0 stand for?
No, okay, so it's giving you, because you will get when you compute A like this is what you get. Actually, I think when we evaluate the integral from A to B fs, you're supposed to get one value, right? One value, and this is the correct value. So when you write 0, that means that you are taking, because this giving you a tuple of 2 values. And the first value, which is at the index 0, is the right one. That's why we want to return the value at the index 0. So I guess here, look, if when you evaluate the integral, you first find the primitive and then find the f of A and f of B, f of A and f of B, and I think the The second value is giving you the value of the primitive of at the last input, something like this. Yeah. So to get the right value of the integral is the first element in the index, the first element in the tuple. Okay.
Please.
Yes.
The second value is not error.
No, noise. I'm hearing some noise. Can you come again with your
I
comment?
said that the second value is not error, for instance.
The error.
Yeah.
Let's look at it. Yeah, depending on because here now you are using a function here. Integrate is a function that is built in Python, and this is giving you the estimation. And okay, when you try to compute or find out the right integral of this by hand, there is some error that Python could have. Yes, and I think this is giving error. Yes, yeah. This is the error that the built-in function in Python, especially for integration, has with the exact value. Yeah. Okay. Good. Okay, so I think we are almost at the time, but let's just look at how we can solve ODE and then we finish. So you can solve first order ODE using Python, and first import NumPy and also import CPy, because we want to use the sub-package integrate. And we also need to import ODE because we will use it at a certain point. Okay. So this is the equation. You can solve any equation at a form, maybe t squared multiplied by y, or t plus y, something like this, in the right hand side of your integral. Okay. So first of all, since you want to solve an ODE, first order ODE, the theoretical way of solving this is to first find the function. What is the function f, t, and y? So you compute that function, you define this function. That's what we are defining here, model y and t. And that function is what is at the right-hand side. Yeah, and dy dt is returning this function. In our case here is minus k times y, but in another situation, you could just write the expression and specify the initial value. Because at the end, when you get in the value of the integral, you find some constants. And so when you want to get that constant, you specify, okay, I want at 0, get 5. And then we are getting actually the approximation of the answer of this solution. So the approximation, we take in t in this list. We know what is a length space. We're taking the first element 0 and the last element as 20, and we want to subdivide this interval into 70. So we have enough point for us to get our value. So our T take element in that array containing I think 70 elements in this. And since you already import ODEnt to solve that, you just use ODEnt model. You write the function that you already defined at the right hand side, the initial value condition with the T, the range where you want to get the solution, and that gives you the solution Y. So also here, when T take any value, you get the Y corresponding. If T take 10, you get the Y corresponding, Y10 here from this Y. And you can actually plot from the X axis, you take T, and the Y axis you take Y. And to plot, you import matplot library before you plot something again. Matplot library by plot as a plot, just an abbreviation. And we want to plot the expression of T against the expression of Y against T. So we have 70 elements in T, and also we have 70 elements in Y, and we are plotting the tuple T and Y in our plane, and we get this curve, and this is our solution. And also it's an estimation, it's not the exact, it's an estimation, because we are taking the point very, 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 very close. That's why you see the curve like this. Okay, so you can also solve system of ODE in Python. You can look at the code. I wrote the code. I think it's easy to understand. You can do some plotting, three-dimensional plotting. If you want to plot in a space, you specify the X, Y, and Z axis, and you choose the range where you want to plot. And this is a multi-variable function. You specify the relation between Z and X, relation between Y and Z, and then you can plot easily the surface. And that's all. I think we need to stop there. So please go through the whole notebook and work on it, work on the exercise. I will send you a set of exercise tomorrow on this notebook, and while you are going to, you could try it. Also, if you have questions, please, the tutor also, I think they will be organizing some special session during the week, maybe once a week, I think.
Prudence.
Yes, Fred.
The last time you said you send us some exercises on the first.
Yes, I sent it. I sent it.
But you haven't seen it, so.
Oh,
Okay.
It is in the folder assignment. In the folder assignment, you will see exercise somewhere there.
Okay.
Yeah, they are there. So those exercises, please, you can try them. Those are on dictionary list and all that we have seen. But I don't think you have some exercise on NumPy and CPy there. So I will send a new one.
Okay.
Yes, and you could try it. Yeah. So the assignments, the next assignment is on NumPy, CPy, and Matplot with we see visualization on how to manage some data maybe next time. So, but I will give the assignment next Saturday, next Friday. Or if you want me to release the assignment even tomorrow, I can release it. But I just don't want to crash with the assignment that you are doing now with other courses.
And sir, what if you release it tomorrow? When will we submit it? When are we to submit it?
Okay, if I release it tomorrow, no, it can be, we can't give you 2 weeks to do assignment, eh? So
But, sir,
yes,
it'll help us like with the perfection of it. That would be nice.
no, it's too much. Taking 2 weeks to do assignment is too much. So I can release it maybe on Thursday before the class, just before the class, and you have a look at it, and you will be submitting the following week.
Okay.
Yeah. So when I release, maybe when you read it, when we meet next time, you can ask some question on the assignment. Okay. But remember, we're having quiz just before the class. Before the class starts, we have 10-minute quiz. Okay, so I can give you, for instance, just ODE to basic ODE, first ODE to solve it using Python, for instance. I can maybe give you a linear system to solve using Python, just basic thing. Or I can give you some data and then, okay, can you plot it for me from all you have seen? So, yeah.
Please.
Yes.
For quiz for next class.
Yes. Yeah, it's next week. The quiz, we are having class on, I think if they confirm the timetable, we are having class next Saturday again. I think the time need to be specified. So before we start the class, we do 10-minute quiz. That's what I'm saying. Okay? Any other thing or concern? No, I'm not hearing you very well.
I have some question in lesson 4.
Okay. On the notebook.
Yes. Lesson 4. The
Yes.
question concern the MyPy.
Okay, so you can share your screen, or if you want to share your screen or to ask the question, is a part of the exercise that I gave.
Yes, it is. I don't understand. Bitcoins and non-zero in lesson 4.
Okay, so what we're gonna do, let's organize a special session with you. Okay.
Okay.
Yes, and we discussed that tomorrow morning, just send me a message and then I will send you a link and we both will discuss.
Okay.
Send me a message. Okay. Because of the time is, I think it's 9 at your side, but it's already 11 at my side. So
Okay.
Okay, so see you next time and enjoy the
Bye bye. Hey. we receive a assignment when we receive assignment.